we start by doing the first one, right? The resistance polyagram. We need to
Come from behind.
draw our line in the 0 mark, and by drawing the line there, we can set up the first one because we're gonna have to draw quite some lines here. So let's just draw our first line. And once you have your first line, of course it's not gonna be able to see because it's on top of the other one. We need to grab our ruler and make the straightest line possible, taking 1/2 inch to the right and 1/2 inch to the left. So you need to kind of balance your ruler until it's like, let's say,
Those gaps are equal length, equal width.
until they're like aligned to.
1/2 inch, like right here and right here.
Yeah, I mean this isn't large, so
Oh,
we probably have to
because
take like
It's
2
tangent,
inches.
right?
So let's say it's at 5 and we take 2 inches, right? So we would go
4.
to 3 and we go to 7. So you see how this gap is less than this one?
Mm-hmm.
We kind of have to balance them until they're like about the same.
Mm-hmm.
And once they're the same, just
The gap between the ruler and the line.
Yeah. Oh shit. Okay, I put the ruler. Yeah, this line is pretty important. So we make sure the line crosses through. Okay, that's a good one. So you know how this one's here?
Mm-hmm.
Brian, so you said this little gap and this little gap has to be
Yeah,
the same size.
equidistant. I mean,
Okay.
they have to be aligned. So you want your line crossing through it
As
as
it's
straight
all-
as possible.
Okay.
You want to hit as many points as possible of the polyagram.
Mm.
And once you do that, you go to, I always do it to the next one, to the next tick mark.
Yeah.
So just put your line here. And it's gonna go around here.
Mm-hmm.
And now you have your values. You just have to take the scale and find your real values.
Sometimes if the scale's really generous, you don't really have to scale it, huh?
No, you don't have to. Okay, so we
Can you
need.
calculate RP?
Brian,
Yeah.
what is the axis, the units on the x-axis? It was mega amps, or was it? Because that's gonna, or amps.
It doesn't say here.
It doesn't
Yeah, but that
Because
units really
it matters,
affects.
though.
Yeah, it really affects.
Yeah, it affects this thing.
Because we always
I
want.
feel like it's milliamp. No wait.
Is that a micro or milli?
I think it's micro unit.
Yeah. Yeah, it's micro. Usually micro.
Because usually it's milliamps, the one that the examples I see, kind of like millivolts, milliamps.
Yeah. Oh here, millivolts.
Oh, so it'll be milli. Yeah. Wait, what the hell? Can you write on this sheet?
Not
I mean, you're not supposed to.
I'm just like,
It's
is this something that happened?
Yeah.
Well,
it's
on
fine.
the exam you'll have time to make the scale, right?
Yeah.
Yeah.
So like 1, 2, 3, 4, 5. Every tick mark is about 2.
Yeah.
But like,
I don't
that's what I'm saying. In this case, you really, if you want to do it fast, you really don't have to scale it because it
Yeah.
goes back to this is
Like this
half.
is large enough to kind of eyeball it.
Yeah, and that
So,
line is clearly half.
2
So
and 3. So 797
Oh, actually, no, I have the answer for this one.
negative 797. And then for this one, oh, don't forget the units because sometimes you forget. Like if you don't put the units here, you forget them on the other
We have
part
a
of
space
it.
until 3.
I think 230.
And then you need this one as well. So this one will be, let's say, 791, negative 781. I mean, yeah, 81.
it's halfway. So
Yeah, I'm just checking because sometimes you confuse the values.
Mhm.
You just like do it wrong. Once you have your values, you can calculate RP, and RP is gonna come out to be.
Are you gonna be starting all day for this?
Yeah, I think so. Just this,
So
element
it's
diagram and
absolute.
that, and
No wait,
programming.
it's not
The
absolute
rest,
value.
like, it's not worth it for me to do it.
Yeah, same.
So they were negative. The one you
Yeah,
put
just
first,
those two things too.
it's going to be the first one that you have here. So don't put the value of 0 first. Put the
It
second
doesn't really
one.
matter though, does it?
No, actually no, because
Because I always put the 0 first.
Yeah.
I'm just like, oh shit, I've been doing it wrong.
I mean it doesn't matter.
Yeah.
It's just the way I do it.
So the bottom, you're gonna put 5
Yeah.
times 10 to the negative 4.
So the bottom, I'll put the same thing. So I'll put 5, well, 0.5 minus 0. Should we convert it to amps?
Yeah, that's what I'm saying. 5 times 10 to the negative 4.
Negative 4.
Because it's
Yeah,
0.5.
that's 0.5. So let's just.
Or just leave it in millivolts and milliamps, and then convert it.
Well, it's just-
No,
convert it
because
here.
once you calculate the other values,
Yeah.
it's kind of messed up if you keep not the right units because of the constants. So
But that means you gotta change this into, because you wanna get ohms, and ohm only works with amps over
Yeah,
volts.
but you'll get the answer in milliohms, and you just convert it to ohms.
wait, so this one it seems
Instead of doing a conversion, you can just save the conversion for the end if you want to.
Whichever makes sense for you, like
Yeah.
if you wanna convert it in the.
wait, PT. What was PT?
PT?
I thought it was platinum, but.
It's platinum, but like
Oh, yes.
So our values.
The reference is different.
Damn,
It's
bro.
usually with
I mean-
hydrogen.
I think he'll throw this one in there.
Yeah, this was.
I think this is the one me and Emma worked on Saturday, and the units on the axis was just MA, not centimeters squared, which fucked me up, cause. So I go find that shit.
No, it has to be centimeters because it's current density.
Is this one right? 650?
Yeah, it's that one.
Yeah, but this one only has MA.
It's not right.
Oh, it's not. Oh, it's not.
I mean, it's
Oh, it's not the
missing
same.
the.
One. It's not the same one actually.
No.
No, because mine is.
Wait, this is the other one.
Oh.
Unit. Yeah.
Yeah, I don't know.
So let's do 781 minus 797.
So you're saying, so before you go forward, you're saying it's wrong. It has to have. Like divided. It needs to be divided by centimeters squared. It has to have.
Yeah, because it's current density.
And
It's
we-
not just density.
And we just disregard the PT, right?
It's current density. It's not just current.
Okay, because I thought I was like, wait, how do we implement? Okay.
Yeah, I remember doing something.
I got 782 and 797. So.
Do we need to convert the
Oh,
I'll let
values?
Evan print it out.
Yeah, me and
Oh,
Evan
me?
were here. Yeah, me and Evan were
Working on it?
studying Saturday.
Oh, he was here
Hey,
Saturday?
do we need to convert the platinum?
I don't know. When we never worked on it, he didn't do anything for the platinum. We
I
just
don't
worked
think so.
for
I
numbers.
think you just do it because I'm looking at the way Alexander did it, and he didn't do nothing like that. He just did it regular.
You have the stuff.
Yeah, this is from last semester. He posted it in the chat. This is how he did it, but he used 1, so that's why you got negative.
See how we have this MA.
Yeah, but like he left it in MV and MA, and then
Wait.
No, he does grade people's test differently.
You know what?
Just ignore
I
the
think it
platinum.
doesn't matter.
yeah, I don't think it matters.
It's just the reference electrode.
Yeah, it is a reference
Right?
electrode, yeah, because usually it's SHE, which is what we use for the EMF table.
I'm just gonna use amps. Okay.
Yeah.
So you just plug this one in here. And you have to do the 0, but it's gonna do the same thing. And RP is going to be equal to Of course, this is a plus now.
Like 32.
Mm-hmm. But since I converted to amps, my value is bigger. Which, I don't know if we should have
Yeah, why-
converted
why
to
not?
amps.
Shouldn't you have converted the volts
Alexander got 30.0.
to 0.781 and 0.797 since it's millivolts? Shouldn't have.
It's millivolts?
Well, shouldn't have been volts
Oh,
because
it says millivolts.
Yeah,
You're
'cause-
right. You're right.
So it should be 32.
So we don't have to convert it since it's both in mils.
Yeah.
Mm-hmm.
Oh, I forgot.
So the
about
answer would be
millivolts.
32 ohms.
Yeah, I mean,
Would it be? But you're saying you're 32 milliohms. So what do you want it in ohms?
Yeah, you're right.
It's whatever he wants it on this little
Yeah.
table. So
Yeah, so you wouldn't have to convert it then, dude. So then it would just be 0.5.
usually he wants it in ohms.
Yeah.
So,
So you
let's
still-
let's just convert everything. This is millivolts, so
Well, why don't you just convert at the end?
no, it's 0.781. We'll do it this way. Everything's
Okay, that's
converted.
fine. That's fine.
So it's the same thing times -4.
Minus 0. I mean, 1. That's alright. It's because he did 1, so I get confused. Oh, fuck.
The other one?
dude.
They reserved this one?
No, we have it.
Till 2:30, right?
Got time. Got
So
like
3?
20 minutes.
Really?
No, I'm just kidding. It's still 2:30. That's what you said, right? You're the one who clicked the time. It said 2:30, right?
Yeah.
Okay.
797 divided by
This is just 32.
yeah. If you don't change the
Yeah,
units,
see?
you'll get the same thing because it's a ratio.
Yeah.
But it's per centimeter square.
Alright, so I'm probably just gonna do that. Just kind of
Yeah, me too. What's the fuck?
it's just along the
Fuck is
volts over amps.
Oh, it's just
that your way-
my
oh, okay.
way
I
up.
was filming like check my crib out from
I
the
know
TV.
this. Okay, so can I erase this?
Yeah. I mean, I don't know how you want to do it.
Yeah, go for it.
Good luck.
Go for it. Okay, this is part
Yeah.
1, or video 1. I'm gonna end it.